Yes. Let us find out how can we find the concentration of the solution. There are two probable ways for finding the concentration of the solute present in the solution, and these two ways are mass by mass percentage and mass by volume percentage. Mass by mass percentage and mass by volume percentage. So in the name itself we can see mass by mass percentage. Mass, quantity of amount present. So the quantity, how much quantity of solute present for the quantity of solution will give mass by mass percentage. The first one is mass by mass percentage. The second one is mass by volume percentage. Mass by mass percentage, which is mass of solute divided by mass of solution into 100. Mass by mass percentage, the amount of solute present. The amount of solute present in the solution we are finding by means of concentration, and that concentration for mass by mass percentage is mass of solute by mass of solution into 100. Whereas the second way is mass by volume percentage, that is mass of solute by volume of solution into 100. To find concentration of the solution by mass by volume percentage, the formula we had is mass of solute by volume of solution into 100. So just when you come back to the mass by mass percentage, we had in the formula mass of solute by mass of solution. So when we add solute and solvent and we are preparing the solution, do you think will the mass of solution will be equal to the mass of solvent? No, the mass of solution will be equal to the mass of solute plus mass of solvent. For example, you are taking 10 grams of salt and you have taken 100 grams of water. Let us assume you have taken 10 grams of salt and you have taken 100 grams of water to prepare salt solution. So just to prepare salt solution we have to add salt and water. That's all. So what could be the mass of the salt solution? Yes, the mass of salt solution is mass of salt, that is 10 grams, plus mass of water, that is 100 grams. The total mass is 110 grams. So in problems there is a chance of asking that they will give mass of solute and mass of solvent separately. Most of you will commit the mistake that you will consider mass of solvent as mass of solution. But the thing you have to do is you have to add the mass of solute and mass of the solution, mass of the solvent. So you will get the mass of solution. So just let us find out the concentration of the solution, mass by mass percentage, concentration of solution for the given example. So let us assume we have taken 10 grams of the salt, 100 grams of the water. If we have to find mass by mass percentage, as we have the formula as mass of solute by mass of solution into 100. Here the mass of solute is 10 grams divided by, so let us consider the mass of solute is 10 grams and mass of solvent is 110 grams. So mass of solution is mass of solute plus solvent, which is 10 plus 100, 110 grams. So when you are finding mass by mass percentage of the solution is equal to mass of solute, that is 10, by mass of solution 110 into 100. 0 and 0 goes cancel and we will get it as 100 by 11, which is equal to 9.09 percentage. So we will get the mass by mass percentage as 9.09 percentage. The same way we can find the mass by volume percentage of the solution. So let us have some example for this. So let us take the mass of solute is 10 grams and the volume of solvent. So now we are taking the volume of solvent. So let it is water as usual. The volume of solvent as 100 ml. Let us assume we have taken 10 grams of salt is added to 100 ml of the solvent. If we have to find mass by volume percentage of the solution, as we have the formula that mass by volume percentage is mass of solute by volume of solution into 100. So here mass by volume percentage is equal to mass of solute is 10 by, we have to take volume of solution. But do we have volume of solution? No, they have given volume of solvent. Then how can we take volume of solution? It is clear that the salt particles will dissolve in the water, and will the volume of the water increases? No, the volume of water does not increases because it got dissolved in the water, means it occupied the places present between the particles of the water molecules. So volume of solvent will be equal to the volume of solution. The volume does not change, but there will be change in mass of the solution. That's what in previous example we have added mass of solute and mass of solvent. In this case, the volume of solvent will be equal to the volume of solution, that is 100 into 100 goes cancel, which is equal to 10%. So the mass by volume percentage is 10%. Thus, we can find the concentration of the solution by means of solute. Next, solubility. We had discussed about solubility yesterday. Whereas solubility is the maximum amount of solute present in the saturated solution at room temperature. This solubility depends on some factors. The rate of solubility or the rate of dissolving depends upon some factors like size of the solute particles, temperature at which the solution is prepared, and the stirring. If we are stirring, it will get faster. So just I had some examples here. So in this I have taken salt. So I have taken some amount of the salt here, powdered salt, and in one more I have taken the rock salt, crystal salt. Here I have crystal salt. Both are salts only, but one is powder form, the other one is the crystal form. The size of the solute is less in this one, and the size of the solute particles is more in the crystal salt. Just I will add I am adding some amount of water to both the containers. Just will keep it aside for some time. Just I am not stirring without disturbing. Just I will keep at the side and see the result after some time. Just meanwhile we will go for the next topic. Till now we had discussed about the finding concentration of the solution and solubility, the factors which influence the solubility. What are the factors which influence the rate of solubility or the rate of dissolving is size of the solute, next temperature, next stirring. So when you add solute to normal water and add solute to the hot water, in which case the salt will dissolve faster, in which case the solute dissolves faster. As we know, it is in the case of hot water because the temperature of the hot water is more. So when the temperature is more, the rate of dissolving also increases. It dissolves at faster time. And the same way, small crystal size, when the size of solute is less compared to the size of solute is less and the solubility will be faster. The crystals, in our case, the example whatever we have taken, we have done now, the salt in powder form will dissolve faster compared to the salt which is there in the crystal form. So the less the size of the solute particles, the faster the rate of dissolving takes place. The same way, just add salt to the water, the same amount of salt to the water as a second sample. First sample, let it be undisturbed, and when you stir the second sample, we will observe in second sample the salt dissolves faster. By stirring also the rate of dissolving increases. So these are the factors which influence the rate of dissolving or the rate of solubility. The next part of the mixtures we have is heterogeneous mixtures. So in middle of the class we have taken two samples, right? One with small size of the salt, that is powdered salt. In one sample I have taken the. Till now we have discussed about the homogeneous mixtures. Whereas in homogeneous mixtures, the particles, the solute particles will be completely dissolved in the solvent and they will form as true solutions. Whereas other type of mixtures we have is heterogeneous mixtures. If you take chalk piece powder into the water, if you stir it properly, thoroughly, will the chalk piece powder dissolves in the water? No, the chalk piece powder does not dissolve in the water, and we will be able to see the chalk piece powder particles in the water. And this type of mixtures will call as heterogeneous mixtures. And in heterogeneous mixtures, the composition of the particles is not same throughout the mixture. The composition of the particles is not same throughout the mixtures, then we will call them as heterogeneous mixtures. Heterogeneous mixtures are again segregated into colloids and suspensions. Colloids and suspensions. Here the difference is the size of the particles will be less. In solution we had two phases like solute and solvent. The same way in colloidal solutions also there are two phases, that is disperse phase and dispersion medium. The two phases in colloidal solutions is disperse phase and dispersion medium. Whereas disperse phase is the particle which is present in the dispersion medium, and this will be less in quantity. The disperse phase particles will be less in quantity and the size of the particles will be more compared to the size of particles in the solutions, true solutions. Whereas dispersion medium, which holds the disperse phase, is dispersion medium. If you take the mud water, the mud particles, all the unwanted dust mud particles are disperse phase and water is the dispersion medium. In chalk paste powder, when it is added to the water, chalk paste powder is dispersed phase and dispersion medium is water. When we add salt to the oil, will the salt dissolve in oil? No, the salt won't dissolve in the oil. It will form as heterogeneous mixture. Their salt particles are dispersed phase and oil is dispersion medium. So here we have the segregation of matter into pure substances and mixtures. Here we have some flow chart here. Here matter, it can be either in solid state, liquid state or gaseous state. It can be segregated into pure substances and mixtures. Pure substances will have fixed composition, means the smallest fine particle will also be a same particle. And the examples are, all the elements will come under pure substances and all the compounds will come under pure substances. Examples of elements, we have copper, oxygen, iron, gold, silver, hydrogen, mercury, etc. And compounds, whereas compounds are formed by chemical reaction between the elements. Examples of some compounds, water, methane, salt, hydrogen chloride, sulfuric acid, whatnot. We have so many type of compounds. And the other side of the segregation we have is mixtures, whereas mixtures does not have fixed composition, means it is composed of one or more or two or more type of substances. They won't get any chemical reaction between them. They are again segregated into homogeneous mixtures and heterogeneous mixture. In homogeneous mixture, the composition of the particles will be same throughout. Sugar in water, salt in water, sulfur in carbon disulfide. These are some of the examples of homogeneous mixtures and heterogeneous mixtures. Again, as I told, they will be divided into two parts, colloids and suspensions. As I told, colloids or in heterogeneous mixtures, the two phases are dispersion phase and dispersion medium. So here, dispersion phase and dispersion medium I have taken. These can be in either liquid state, gaseous state or solid state. The dispersive phase and dispersion medium can be in gaseous state, liquid state or in solid state. We have different combinations here: dispersion medium, dispersive phase. I have some examples here. What do we call that particular colloid type as? And we have some examples here. If you see DM here, I have taken the dispersion medium in short form. Dispersion medium. If dispersion medium is gas and dispersive phase is liquid, we will call such colloid as aerosol. Dispersive medium is gas and dispersion phase is liquid, we will call as aerosols. Examples: fog, clouds, mist. If dispersion medium is gas and dispersive phase is solid, and we will call it as aerosol. Example: smoke, automobile exhaust. It's like the smoke, whatever